Hey, good afternoon, everybody. Tim Walsh coming to you live from the Illinois Fire Service Institute on the campus of the University of Illinois. We're going to let you get signed in here today for our afternoon delivery of pump operations. We'll give you a minute or a minute and a half here, and then I'll be back with you to introduce today's instructors. Thanks for joining us. Hey, good afternoon, everybody. Tim Walsh coming to you live from the Illinois Fire Service Institute on the campus of the University of Illinois. Glad that you're joining us again here on the Facebook forum. Today I'm joined by Engineer Tal Pendergrass from the Urbana Fire Department and Engineer John McCann from the Normal Fire Department. So we're going to be talking about pump operations today. Hey, chime in the comments section. Let us know where you're watching from and send us your questions. This is a hands-on delivery. We'll be using the pump simulator behind us today. So we'll be covering a lot of topics. If you have anything for us, just chime right in right away so we can get to your questions. So without any further nonsense, I'm going to turn it over to Tal and John. Gentlemen.
Welcome. Thank you for joining us today. The first thing we want to discuss is pump operations and how the pump actually works behind the pump panel. The more we understand about what goes on behind the pump panel, the better pump operators we are. We're able to predict what's going to go on instead of just reacting to it, so the pump operations are a lot smoother. So we'll take a look at what a pump panel what a pump looks like behind the panel. This is a very simple drawing of it, but we see we've got the intake coming into the pump housing, the discharge, and then we've got 3 individual discharges here. So a pump is designed to flow several different flows, various pressures through different lines, and so that allows us to be very flexible in our operations. So how that works is we've got water comes into the pump, pump's turning, we've got the discharge manifold here, and water goes out all 3 of our discharges. The way we adjust the flow and the pressure is through our individual discharges, our individual valves right here. So as you can see from this, the discharge on our number 2 discharge, the valve is all the way open. So we're allowing the maximum amount of water to flow through that line. And so this is our highest pressure line. We've got 180 PSI on this line, which is also the same pressure as what the pump is developing. So on our number 1 discharge, we see that we've got that valve partially closed. So we've got it gated down, so we've got 50 PSI friction loss. We've got 130 PSI on the discharge, and we've backed that down. So the number 3 discharge, we've got almost all the way closed, so we're only getting 90 PSI out of that discharge. So that's why it's important for us to look at these individual discharge gauges as we're gating and feathering and charging lines. The next thing we want to discuss is the pressure control devices. So typically there's a pressure relief valve and a pressure governor, and they work differently. So the first one we're going to discuss is a pressure governor. So it works by reading the pressure in the pump and then adjusting the engine RPMs up or down to increase or decrease the pressure. So with that, what you'll have is you'll have a sensor right here on the discharge side, right outside of the pump, and that's reading the pressure that's right there, basically the pressure that the pump is developing. So as the pressure goes down, in the pump, the engine RPM, the governor will see that, and the engine RPMs will go up. As you open up another line, that pressure goes down, engine RPMs go up. As you close a line, then the pressure will go up and the engine RPMs will go down. So that's the pressure governor. The pressure relief valve is mechanical and it works differently. So it's right here and it works like an additional discharge line. So we've got all 3 lines flowing. As we shut one line down, the pressure on these other 2, the pressure increases, which goes to these other 2. The pressure relief valve is set with a spring, so the increase in pressure pushes that valve down, causes it to open, and it causes that water to flow back into the intake. So that's important to understand that we're not losing water when that relief valve opens up. It's going back into the intake side, so we're not dumping any water in the ground. Does anybody have any questions about either of those, how they operate? So next thing we'll do is we'll move over to the pump simulator, the pump panel. So we'll discuss, we've got our master intake gauge, our master discharge gauge, and then we've got our various individual line gauges. We've got our throttle control. Right now this is set for manual control with the relief valve. So we've got our throttle control, and we've got our relief valve. Here in a little bit, after we do this demonstration, you'll see the governor, and we'll go over the operation of that. So right now we're going to get going with a multiple line operation. We'll show setting the relief valve, going through its operation, how it works, and then we'll move to the governor. So first thing is we always want to have water in. So the first thing we need to think about is water in. How do we get water into the pump? In this case, we're going to use the hydrant. So I'm going to open up the intake. And here we can see we've got about 40 PSI coming in from the hydrant. We've got positive discharge. So the discharge gauge is reading higher than our intake gauge, which indicates that we do have the pump turning. It is developing pressure. So the first thing we're going to do is we're going to open discharge 1, which is our blue line. We're going to charge it to 130 PSI. So we open that discharge all the way open, and we're only at 110. So we need to increase the pressure, so we throttle up.
Okay, so you'll see as he starts throttling up, with only one line off, these two numbers are going to be pretty close to the same. So if we're really only flowing one line, maybe the pressure governor isn't, or the relief valve isn't something we have to worry about right away. But once he's got that set, so we're at 130 here, we're about 130 here. So now, if we want to charge a second line for some reason, let's say we're going to charge one to 180. We're going to open up this discharge. Cal's going to start throttling up, because when he opens this up, with the flow, this pressure is going to drop down a little bit. So he's going to have to throttle it up to maintain this pressure. Whenever we're bringing second lines or additional lines in, One thing we want to watch is we never want to go more than 20 pounds, or we want to stay between 20 pounds. So at 130, we want this to go above 140 or below 120 in that. We want to keep it in that 20-pound range. Okay, so now he's got both of them open, but we still want this one to be flowing at 180 PSI. So what Tal's going to do is he's going to turn the throttle up to get the engine to move faster, get that pump to turn faster, while he's slowly closing this valve down to maintain that pressure.
Hey, Tal.
Yes, sir.
I got one question for you. Sorry to interrupt. So we had a question about setting the relief valve in the proper position when it's not being utilized and how that affects the engine. What's probably the best course of action to get that done, and how should you do it? So let everybody know about it. Thanks, John Williams, for that question.
So setting the relief valve, we'll go over that actually right now. So we've got the pressures dialed in. We're at 180 on our yellow line, 130 on our blue line. So we've got those lines going. Now it's time to set the relief valve. So with this style relief valve, it's got one light and the handle. So we turn the handle down slowly until we get close to where we think the pressure is. Then we slow down a little bit more. So what we're looking for is we're looking for this light to come on, and then we're also looking for this pressure to start dropping. Those will be the two indicators. A lot of times you'll see this pressure drop before you see this light come on. So there the light comes on, so that means the relief valve is on. What we don't want to do is go too fast and overrun this, and now you see the pressure on our lines has dropped down to 130. So that's way below where we want to be for either of these lines. So we'll turn that back up until the light goes off, and now that relief valve is set. So now what you'll see is if one of these lines shuts down, the relief valve comes on, the pressure on the blue line stays the same. If they open the nozzle back up, that comes up, relief valve goes off. Ideally, the relief valve should be set so that the valves, or so that the light stays off when you're in normal operations.
Okay, so now we want to bring another line in, and we're going to charge this third line to, we only want it at 90 PSI. So it's going to be operating at a lower pressure than the other two combined. So basically what Tal has to do is just very slowly open this valve and control it until he has 90 on here. We don't have to do anything with the relief valve because remember that's set to our highest pressure. Okay, so that shouldn't affect anything. All he's going to do is slowly open that valve. Now one thing to remember while he's doing that is we have roughly 180 pounds of pressure on the other side of that valve. So if we weren't on a simulator, if we were on an actual pump, that's a lot of pressure to open up. So it could potentially, when you first open that, you're going to see a drop in the pressure. So that's a natural thing. Let that happen. And then once you get that where you want it, then we can readjust everything to where our pressure is right. Okay? So now, if you look at it, we've got this one flowing 90, this one flowing about 130, and this one about 180. So everything's pretty well set. One thing to keep in mind when you're not using the relief valve, or when you first start your shift or whatever it is, we try to keep that open all the way, maybe back it down a quarter turn, so we're not putting pressure on that spring. We don't want to set it at one spot and leave it there. Okay, that's a mechanical spring. It can develop weak points or a memory or something like that. So we want to get all the way up and then back it down about a quarter turn, so we're not putting pressure on that spring all the time. So that is how we control multiple lines with the relief valve. So we're going to reset the simulator here.
Hey, just wanted to thank all the departments from all across the state and the country that are chimed in and watching us and sending us questions. O'Haron, Heron, I apologize, Missouri, the whole shift is watching at an IAF location, and we appreciate your questions, guys. Keep chiming in. We're going to change over to the pressure governor now and talk about how to do those same operations, not using the relief valve. We know that different departments either have a pressure governor, a newer engine, or a relief valve. So we're going to go into both topics to make sure that we've covered both angles. Tal?
Thanks. All right, as Tim said, now we're going to discuss operations with the governor. So now for the simulator, these controls are dead. We will just use the governor right here. So we'll do the same operation. We're going to start with the blue line, our first discharge. We'll open it all the way up. And most governors default to the pressure setting or PSI setting. So what we'll do is we will throttle up, increase that pressure to 130. And depending on the age and manufacturer and style of your governor, some of them react quicker than others, some of them operate a little bit differently, but most of them are going to operate generally the same, so that's how we'll operate this one. So right now, we're at 130, we've got that discharge set. So the nice thing with this being in pressure mode is that it's going to automatically regulate the throttle for us. So we don't have to use the hand throttle as we open up that second line to get them both open to the same pressure. The difference is that this is reacting to what we're doing instead of us being proactive where we can throttle up a little bit before we start that. So because of that, our operations need to be slower so that the governor has time to see that change and react accordingly. So John's going to open up our yellow line, which eventually we want to get up to 180 PSI. But for right now, we're going to open it all the way. Both lines are now at 130, and you can hear and see the RPMs go up on the governor. It sees that drop in pressure. It's throttling up to get our pressure back to 130, so it maintains 130 on both lines. So that's great. Both lines are flowing at 130 PSI. Now we still want to get the yellow one up to 180. So John's going to gate back the blue line, and he's going to increase the throttle at the same time with the goal of getting the throttle up to 180 PSI. So you can hear the RPMs going up as he's throttling up. The blue line's at 130, yellow line's at 180, so we've got that set. So now where we had to take the extra step with the relief valve and set it now, because we're in PSI mode or pressure mode, the governor is going to automatically sense that pressure and it wants to maintain 180. So as we close the yellow line, say they're closing the nozzle, it sees that, and you can hear the engine RPMs go down. You'll see the pressure starts to go down, but it's maintaining 130 on the blue line. So now we can open that back up. Initially you get a little bit of a drop in the pressure, and then the governor sees that, it throttles up and gets that back up to 180. So now we're back 180, the governor is working, so now we want to get our third line in. So the red line's going to 90 PSI. So we open that up slowly. We're going to get a drop in pressure. The governor is going to control the engine RPM, bring it up, so that we can supply that line as well. And sometimes it'll take, depending on the style of governor, it'll take a minute for it to even out. It may overrun the pressure just a little bit and then drop it down, but eventually it'll even out where it needs to be. So right now we're at 180, and then the yellow line is flowing 180, which is our highest line, blue line's at 130, and now the red line's at 90. So we've got all three lines in operation. So now the other mode is RPM mode. So what RPM mode does for the governor is it basically turns this into a throttle control. It takes the pressure control out of it, so it's no longer looking at the pressure. It's only looking at the RPMs of the engine. The one thing is, depending on your style governor, it may have protections in place where if that surges beyond 30 PSI, it will actually take control and it will throttle down automatically. So manufacturers do that, some of them don't. So it depends on your style governor. That's why you need to go out and practice with it and see how yours actually reacts. So we're going to change this into RPM mode. So now we're in RPM mode. Before, when the governor was in pressure mode, remember when we closed one, it automatically throttled down to bring the pressure to 180, and then it throttled back up once we open that back up. In RPM mode, it's not going to do that. It is going to maintain that RPM, so we'll see a spike in the pressure. So here we see our pressure going up to about 210. So because it's 210, that's that 30 PSI spike. So this kicked in, and it actually brought that back down, so that the pressures on the other lines weren't exceeded. So that's one issue with using RPM mode.
So Tal, we had another question come in, Tal and John. And John, it's your birthday today, right? Somebody just told me. So happy birthday, John. I forgot to mention at the beginning of the show. So which compensates quicker, pressure relief or the other valve? I forgot the question because I was teasing John about his birthday. So I'll go, pressure relief or pressure compensating? Let me look at my question again. I apologize. Pressure governor or pressure relief? Which compensates faster when you're operating the engine?
So honestly, it depends. So with the pressure relief valve, the issue is it's mechanical. So because of that, it has to be operated regularly and it has to be maintained. If you've got a well-maintained and well-maintained pressure relief valve, it will operate very quickly. The issue is if it doesn't get operated, it'll gum up, and a lot of times it will take. There's a long delay before that governor will actually see that pressure and start regulating it. So and then it also depends on the governor, because some of them. So the nice thing with the pressure relief valve is you know what's going to happen. So the operator can anticipate and make corrections before that. We can start throttling down before we start closing that valve, because we know what's going to happen. With the governor, it's waiting to see a change in that pressure before it actually takes action. So sometimes that can be a longer delay too. So it depends on the manufacturer, depends on how well the relief valve is taken care of and maintained and operated to tell you which one is faster or not. So just be mindful that really all of it lies in the pump operator knowing what's going on, understanding what's happening behind the pump panel to be able to anticipate those changes so that they can make the actions that they need to shorten that time span of what that delay is. So,
one thing that will help with that too is when you do your checks, if you have a relief valve, is don't set that at the same pressure every time you exercise it. If you do a weekly check, a daily check, whatever it is, set that pressure at 2 or 3 different pressures in there where that spring is not operating the same way every time. That way it won't build up that memory or get gummed up. So if you do it at 2 or 3 different pressures each time you do it, that kind of exercises it a little bit more, keeps it in a little better, useful shape.
So let's reset that. Let's go over a daily check. So let me shut this down. Go ahead. So what we're going to do right now, we're going to reset the simulator for the pressure relief valve so we can actually demonstrate doing that daily check real quick, so you see what we're talking about with the operation of it.
Hey, Tal and John, we have one other question come in that you can cover after you go daily operational checks, and that's at a long stand, you're flowing water for a long time. How do you keep the pump cool? How do you circulate water? And what's the proper way of doing that depending on which type of system you're using?
Okay. So the circulation of water, that doesn't really depend on the relief valve or the governor. If we're pumping for a long operation, what we want to do is we want to crack the recirculation line and allow it to circulate water through. Most of them also have an auxiliary cooler that you can open up, which bypasses water, pump water, discharge water through the radiator to help exchange that so that it'll help keep the engine cool and the pump water. Go ahead. So for a daily or weekly operational check of the engine, what I'm going to do, I'm going to get water in. So we're not operating off the hydrant, we're operating off the booster tank. So I'm going to open the tank to pump. So we got to get water into the pump, and then we got to get water out. So I'm using my my tank fill and recirc line, so I've got water moving, and then I'm going to throttle up. So I want to have the operating range of the pressure control devices is 90 to 300 psi. So I need to be over that 90 psi. So typically I'll use a pressure somewhere around 150. As Johnny said, you want that pressure to be different normally, but 150 is a decent number to use in that area. So I get my pump pressure up to 150, and then I set the relief valve, just as we described before, turning to lower until the light comes on, and until I see a drop in that pressure. We're gonna have to reset the simulator here.
Hey guys, we appreciate your questions coming in. Bobby Williams just sent us another question, and we'll get to that after John and Tal demonstrate the answer to this last question. But they want to talk about winter operations a little bit. Is it proper to run the pump without water in it, depending on the temperature? I know that most departments have an SOP on winter operations. I know where I came from, we did. It was specific to our department, but what would you guys do as professional engineers?
So that depends on your department, like Tim said. We typically use wet pumps all the time. So with our winter operations, what we'll do is we will open the tank pump and open the tank fill, and then engage the pump when we're sitting on a scene. So that way you've got water circulating through the pump so it won't freeze. You know, the moving water won't freeze. You can empty your pumps and have a dry pump. The issue with that is that you need to make sure not only is the pump dry, but all of your individual bleeders here are dry as well. And then you also need to take the caps off of your discharges so that you make sure that there's no water stuck in there. So even though your pump is dry, if your discharges have water in it, then that has a tendency to freeze up.
Sorry,
That's all right.
another question. So we had another question coming from John. When is it best to pump in RPM and pressure?
Okay. So we'll actually cover that here in a minute. Really, you want pressure mode anytime that you've got multiple lines going. So that gives you that pressure control, so if one line shuts down, it doesn't overpressurize the other line. You really want to be in RPM mode when you're switching from booster tank to hydrant, or from booster tank to draft. Anytime you're changing water supply, you want to be in that RPM mode, because otherwise what can happen is you can have a change in that intake pressure. In that change, so say it's a drop, the governor will see that and it will throttle up, and then all of a sudden you'll get water, so you'll have a huge spike on that. The governor will see it, it'll drop it down to idle, and then you'll keep roller coastering, basically lay up and down until the governor figures out what's going on and things stabilize. So to minimize those spikes, you want to be in RPM mode so that you have control over that, because you know what's going to happen. You can predict what's going to happen, so you've got control over that throttle, and you can maintain that pressure where you want it. So we'll go over that daily check again. So as we said, we'll open the tank pump, get water in. Recirc lines, we got water out. We'll run the pressure up to about 150. And then we'll adjust the pressure relief valve down. Until it comes on. We'll adjust it back until the light goes out. All right, so now the relief valve is set. So in order to get that valve moving, what I want to do is I want to close my discharge. I want to close that recirculation line. So I'll close it, relief valve will come on, and then I'll open it back up. Relief valve will go out. So that valve is actually moving inside the relief valve itself. It's exercising that spring in the valve, which adds lubrication to it, so it'll work itself out. it'll adjust, or it'll loosen up, thank you. It'll exercise. So you do that, so I normally do it, and especially it depends how that valve reacts the first time I set it. If it's working well, I'll run it 5 or 10 times. If it's really sticky and it's not wanting to operate, I'll run it 10, 15, 20 times until it starts to loosen up and until it responds the way it should. This is acting the way it should. This is a well-maintained relief valve. So when I close this, the light comes on pretty quickly. When I open it back up, the light will go out. So that's the way the relief valve should respond. If it's taking longer than that, then just work with it back and forth until you get that relief valve to loosen up.
Okay, we have one other question come in, guys, and I think I can handle this one, but I was never an engineer, so you're gonna have to coach me up on this. So the question was, how do we know what lines and what pressures to operate at? Well, that comes into a lot of factors, right? We need to know the diameter of the hose, how long the lead out is, and the pipes that we're using on the ends of those hoses will determine operating pressure at the panel.
Right.
So it's different for every department. Is there anything that I'm not covering there, or something that you need to
So-
talk about, Taylor, John?
There's two things with the nozzle. You need to know the type of nozzle, because the nozzle pressure for a smooth bore is different than the nozzle pressure for a fog. So typically a fog is going to operate at 100 PSI and a smooth bore is going to operate at 50 PSI. And then we also need to know about the GPM, the flow. How much is that nozzle flowing? So those two things, plus like Tim said, the size of the line and then the length of it will all help us determine what that friction loss is.
One of the other questions that we had come in, and we talked about it a little bit before, and it was always a concern of mine, like we talked about, I was never an engineer, right? So this was send the water, more water, less water. That's my engineering background. But it's your first day, you're the acting engineer, or it's your first day as an engineer. Can we talk about putting the first line in service? Because as a company officer, I always said to my new engineer, hey, are you gonna be able to get me water today? And we would take the engine out and we would practice in the morning, obviously, to make sure we could do it. But let's talk about getting one line in service, an attack line at a fire.
Okay. Do you want to do this? Yeah. I'll get things reset here. So. We're resetting the pump panel now. So everything would be just like it is once you get out of the cab of the truck. So first thing is you want to make sure that the pump is turning. So there's a couple different ways to see that. The first is you're going to see a green light here or an okay to pump light. The next is a lot of trucks have a pump panel light that comes on when the pump's engaged. And then third, if you've got water in the pump, you'll see a positive pump discharge. So Johnny opened up the tank to pump. So we've got water in the pump and you see a discharge pressure there. So that tells us that the pump is turning. So once we get once we get the pump turning, we want to get water into the pump. That's the first thing. So where are we getting that from? In this case, we're getting it from the booster tank, so we open up the tank to pump. If we're using the hydrant, we open up our intake valve here. So we got water into the pump, from the tank to pump. Now we need water out. So Johnny's getting water out. We're using the blue line, 130. He's going to throttle that up to 130. So as you can see, we get that first line flowing. We're starting to lose water out of our booster tank because that's what's flowing out. So when we have that, when we've got water flowing from the booster tank, we want to tell our officer, once we get down to half, call them on the radio, let them know, hey, you're at half. Once you get down to a quarter, hey, you're at a quarter. You want them to know where they're at with the amount of water so they can know how far in they can go or what operations they can be or if they need to go to a safe place or get out. So watch that booster tank, communicate that with your officer. Once our hydrant line's hooked up, we open up the intake. And we're gonna have to throttle down. We want to maintain that blue line within 10 psi above or below. So if it's at 130, we don't want to go above 140, and we don't want to go below 120. That keeps the pressure fairly consistent for whoever's on the nozzle, so that they don't see a big pressure spike or they lose pressure. So once we get that dialed in, you can set the pressure relief device or the pressure control device. Really, you don't have to set that until you get 2 lines flowing, because if they shut down that the nozzle on the blue line, the pressure's gonna go up, but it's not gonna negatively impact any other lines because you don't have any on. Once you have multiple lines is when you want to set that relief valve or the pressure control device, the pressure governor. So now he's got that set. We've got water coming in. The last thing we want to do is we want to fill our booster tank. This is our safety net. So if something happens, if somebody runs over our supply line or it's compromised for some reason, we've got a safety net amount of water up here to get that crew out before they lose water.
So I got a question for John McCann specifically now, Tal, so we're
Okay.
gonna have John answer this one. Hey, John, we talked about it a little bit earlier, now that companies are running with less people and less manpower on the fire ground, maybe
Okay.
you're only pulling up with a 2-person engine or a 3-person engine. Let's talk about putting a deck on the work, because it's a little bit different. And knowing what we know from NIST and UL firefighter safety and the studies that we've done here, the evolution of using quick tank water right away to operate that deck gun is a key indicator to knock down fire, and it helps on the fire ground, right?
Okay.
So
Okay.
let's talk about that.
All right, so let's go ahead and we'll shut this down and we'll get that reset while we're talking about it. So I'll go ahead and shut this down, we'll get this reset. So one of the things we want to do is we've always talked about when we're flowing a line, that first line off, you want to get it charged, opened up, and then bring it up to pressure. A master stream operation is going to be a little bit different. What we're going to want to do is we're going to want to bring that up to pressure before we open that. Excuse me, because if we open that and then we bring it up to pressure, that's a big opening for water to flow out of. We're going to lose a lot of water out of that till we get it up to pressure. So if we're doing that,
We're doing this off booster, right?
yeah. So if we're doing that, first thing we always want is we want to make sure we have water coming into the pump, right? So I open that up, I get water coming into the pump. We're going to set that up to the right discharge pressure. Hold on, we're having technical difficulties. We had a little bit of a touch, so what we want to do, like I said, is first thing we're going to do is we're going to get that up to pressure, okay? So, first thing I do, I want water coming into the pump. I look at my discharge pressure, I see I have building pressure in there, so I have water in the pump. Then when we get this set up to about where I want it, typically between 180 and 100 psi is where we're going to want that master stream. Then we get it kind of aimed where we think it's going to go, where it's going to do the most amount of good for that fire attack. Then I just slowly open that gauge, and when I open it, you see that pressure falling a little bit, so I adjust my pressure back up, keep an eye on that. And then I have that flow coming out of my master stream device.
All right, so one last question, which we kind of talked about, and then we'll kind of wrap up for today. We had a question about using the finger method for pressure systems, right? For losing pressure. I know there's a lot of different systems. I know what I encourage my engineers to do was to write it on the inside of the cabin on the engine, so it was available to them and look at it. But we can talk about the finger method quickly, not in a real depth. This is not an engineering class, it's a pump operations class, but let's just give a brief overview, please.
Okay, so basically the finger method that Tim's talking about is a way for us to figure out the pump pressure we're going to have on the fire ground real easy. You use your tips of your fingers for how many gallons you're flowing, and 100 gallons a minute. So 100, 200, 300, 400, 500. And then you just put even numbers down here, 2, 4, 6, 8, and 10. So if I'm flowing 300 gallons a minute, I go 1, 2, 3, 3 times 6 is 18. So I'm gonna lose 18 pounds of pressure for every 100 feet of 2.5-inch hose I have. There's ways we can do that after we do it to convert it to 3-inch or 4-inch, whatever you guys are using. For our cross lays, typically 1 3/4 inch, something like that, that's a given number. If we're flowing a certain amount through 1 3/4 inch, we're gonna lose a set amount every 100 feet. That's a given, that's given to us by the manufacturer. The easiest thing you can do is figure that out for your department and make a pump chart that drivers can keep there, write it. I've seen departments where they put a piece of tape on here that tells them what it is, or write it down with a grease pencil, something like that. That way at 2 o'clock in the morning, you're not trying to do math, so.
Hey guys, I wanted to thank you for your time today, and obviously we covered the pressure relief valve, and we covered the pressure governor, how to operate multiple lines today, how to check out the engine first thing in the morning to make sure that we can get water out of it and the pump is operating, and how to put the first line in service, and how to operate a deck gun. So I think we've covered pretty much everything that could happen to you your first day as an engineer. Hopefully you don't have a big long water stand. That's a whole other topic that you can come down to the Fire Service Institute, and John and Tal can teach you about that. We appreciate you being with us today on the Facebook forum. Let's talk about the stuff that we have coming up. We've been listening to you. You guys have been emailing and texting us, telling us what you want. So coming up tomorrow at 4 p.m., we have a state agency update on the Facebook forum. So leaders from all over the state are going to speak to you, the responders on the street, about what's going on with COVID and how we're going to go forward in the future. So that's tomorrow, 4 p.m. on the same Facebook channel. And then next week, I'll be joined by Larry McCormick and Eric Trokin from the Chicago Fire Department, and we'll be covering flat roof operations, much like we did with peak roof operations with the Milwaukee Fire Department last week. And then on June 5th at 11 o'clock in the morning, Sammy Vega and the engine operation guys will be on campus, and we'll be talking about putting the first attack line in service on the fire ground, and we'll be doing some live fire training. And then later on in the month of June, we'll be doing first due company officer to a bona fide technical rescue at a confined space incident, and first due company on the scene of a building collapse to get you ready for the spring tornado season. Also, the preliminary exposure bucket reduction project is in service. You need to sign up on our website. It's a state of Illinois project in conjunction with MABUS, where we're administering decon buckets to fire departments all across the state of Illinois with a plan on how to decon members on the fire ground so that we can keep you healthy. You can log into fsi.illinois.edu/decon to get your free stuff from the State Fire Marshal's office so that you can properly decon yourselves on the fire ground. So watch for us on the Zoom platform and Cornerstone delivery coming up. And in future weeks, we'll have multiple programs for you guys. We're delivering free programs here, free training for the fire service, and we appreciate you being here. So keep those emails and questions coming in so that we can provide for you the first responders in the state of Illinois and across the country. Thanks for joining us today.